Hey class, this is this is geometry, sorry. Geometry section 8.2. And remember from 8.1 we were talking about right triangle similarity? Well, now we're going to talk about right triangles, and we're going to finally introduce you to what we call trig, or trigonometry. The trig ratios for a right triangle involve the pieces of the right triangle that we already know. So on your handout you'll notice that the hypotenuse is labeled, and that both legs are labeled. One leg is labeled as the leg opposite angle A, and one leg is noted as the leg adjacent to angle A. You're going to see me label these as capital A, capital O, and H. So what I want you to do is, we're going to, at the very top of our page, and this is what we're going to do every time we start a worksheet for the rest of this chapter, is we're going to write a little Indian name called SOHCAHTOA. SOHCAHTOA, if you can remember that, has to do with three trig ratios. So let's go ahead back down to our box and let's fill in the SO. So, or SOH, says that the sine, looks like sin, but this is not religion class, so don't say sin, it's sine, of angle A. As soon as I tell you I want you to find the sine of angle A, I want you to go over to angle A and mark it as a reference angle. Then next I want you to put the side opposite A with an O, and the side adjacent to A with an A for adjacent. And of course the hypotenuse is always H. Well, SO, or sine, has to do with opposite over hypotenuse. And since the opposite side from A has a length of 4, we're going to put a 4 there. And since the hypotenuse has a length of 5, we're going to put a 5 there. We can type that in our calculator and we get 0.8. Let's do the next one for CA. So CA stands for cosine. And we will not pronounce this cos. It's cosine. Cosine of A, since we're using the same reference angle, we don't have to mark it, is adjacent over hypotenuse. The adjacent side to A, remember we marked it right here, has a length of 3. Typing that in your calculator gives you a decimal of 0.6. And the last one is TOA. TOA stands for tangent, T-A-N, of A. Please do not pronounce that tan. We will always say tangent, equals opposite, which is 4 over adjacent, which is 3. We get approximately 1.3 repeating. Okay. Now the next thing we're going to fill in is we're going to use the SOHCAHTOA relationship for our special right triangles. Remember we started the semester with these special right triangles. I told you that we would be using them often. The first type of special right triangle is already drawn for you. It's a 45, 45, 90 triangle. And if you remember, there's a relationship between the hypotenuse and each of the legs. The hypotenuse is radical 2 times however long the leg is. Jumping to our 30, 60, 90 triangle, we remember that the short leg, which is X, and the long leg have a relationship, that the long leg is always the short leg times the square root of 3. And if you remember, the hypotenuse is always 2 times the short leg. Okay? So what you see here is kind of spelling that out. We're going to use those sides when we write our SOHCAHTOA relationships. As soon as you see sine, you're going to remember that sine is opposite over hypotenuse. I'm going to erase all these markings real quick. We're we're doing a 45, 45, 90 triangle, and our reference angle for this one is the 45, so let's mark it. It doesn't matter which one since they're both 45. You can mark either one. Opposite is over here, and hypotenuse is up there. Of course, this is adjacent also. So we're going to fill this in. The opposite side to 45-degree angle is listed as x. That's how long it is. The hypotenuse for angle 45 is x radical 2. The x's are going to cancel. We're going to get 1 over square root of 2. Now, remember that when we have a square root in the denominator, we have got to rationalize the denominator. In math, it's okay if we multiply by something that equals 1. We pick the square root of 2 over the square root of 2 because this helps me get rid of that radical. So in the numerator, I have 1 times the square root of 2, or the square root of 2. And in the denominator, I have the square root of 4, because 2 times 2 is 4, or simply 2. And that's the answer to the sine of 45 degrees. So the sine of 45 degrees equals square root of 2 over 2. All right, I'm going to do a couple from each section, and then you need to finish the rest. So let's start with number 1. Number 1 is asking us to do sine. So the first thing I'm going to do is I'm going to write opposite over hypotenuse. Okay, if you want to just for reference here, SOHCAHTOA. I know that sine is involving opposite over hypotenuse. The next thing I'm going to do is I'm going to go over to my picture and I'm going to mark my reference angle K. Then I'm going to put little dashes here. This is the opposite for K, this is the adjacent for K, and this is the hypotenuse for K. So sine of K is equal to the one we marked opposite, which is 15, and the one we marked as hypotenuse, which is 17. Typing that in our calculator gives us 0.88, and they asked us to round to the nearest hundredth. Number 2 is cosine. Okay, we're changing our reference angles. This is a little bit confusing. I'm going to erase my marks. Maybe you need to redraw your right triangle if you're using pen. If you're using pencil, just go ahead and erase your marks. Our reference angle is now H, because that's what we're doing. For H, this is the opposite, this is the adjacent, because it's connected to it and not the hypotenuse. And the hypotenuse is always the one across from the right angle. Cosine, remember, back to our SOHCAHTOA, is adjacent over hypotenuse. So we're going to put adjacent over hypotenuse. We're going to fill in the A, which is 15. We're going to fill in the H, which is 17. Typing that in my calculator also gives me approximately 0.88. Let me point out here that the cosine of one angle of a right triangle and the sine of the other are always the same thing. Okay, you try number 3 and number 4. Mark your reference angle. Put your fraction letters there. Remember, tangent is opposite over adjacent when you do your fraction, and go ahead and mark your reference angle. Okay, let's jump down to number 5. Number 5 is asking us to do cosine of 45 degrees. Now, I'm just going to go ahead and draw the picture. Okay, you don't have to redraw these pictures because yours is still on your worksheet, but I can't see mine on the screen, so I just went ahead and redrew them real quick. These are the special right triangles, and I do expect you to memorize these. So let's start with number 5. We're doing cosine. Cosine is ca, or AH. So the first thing I should write is adjacent over hypotenuse. If I go over to my picture and mark my reference angle with a little arc mark just to get me organized here, I recognize this is opposite, this is adjacent, and this is the hypotenuse. So when I go to fill in A and H, it's simple. I write x over the hypotenuse, which is x radical 2. Now, x and x cancel. We know that anything divided by itself is 1, so I need to put a 1 there. What happens next is, let me change colors here. It's the same thing that happened above. I'm left with cosine of 45 equals 1 over square root of 2. Well, that's not in simplest form. I got to get rid of that radical in the denominator. So I'm going to multiply by square root of 2 over 2, and I'm going to get square root of 2 over 2. Remember these two, that's the same as square root of 4 or just 2, and that's how come the denominator became a 2. All right, I'm actually going to do 7 this time. 7 is involving sine, and it's also involving 60 degrees. Sine for so is opposite over hypotenuse. Go over to my picture. What am I going to do next? Yes, mark the reference angle. If I mark that angle, that makes this the opposite, the side opposite. That makes this the side adjacent or next to or touching. And obviously this is always your hypotenuse. So when I go to fill in my numbers, it's easy now. Opposite is x radical 3. Hypotenuse is 2x. And this one, the x's cancel. I'm left with square root of 3 over 2, which is the final answer because I don't have a square root in the denominator. So the sine of 60 degrees is equal to the square root of 3 over 2. All right, I need you guys to try number 6 and number 8. Okay, we're past 11 minutes, so I'm going to go ahead and stop here. I do want you to finish these 4 problems that I didn't solve for you. We're going to actually finish the back page tomorrow, taking notes, and then we will continue to practice trig. You guys have a great night.